Synchronous motor, a device which converts AC electrical energy into mechanical energy running only at a synchronous speed, is called a synchronous motor. In this motor, the speed is constant. It working on the principle of magnetic locking. The rotating magnetic field plays an important role on its working. A three-phase supply, the field is produced as a rotating magnetic field. It rotates the speed at synchronous speed. N of S is equal to 120 F divided by P. F is the supply frequency, N is equal to number of poles. It consists of stator, which houses the three-phase armature winding in the slots of the stator core, and receives a three-phase supply. The stator is wound for the same number of poles as the rotor poles. A rotor that has a set of salient poles excited by DC current to form alternate N and S poles. The exciting coils are connected in series to two slip rings. This is a construction of synchronous motor. Here the type of rotor will be two types, cylindrical rotor and salient pole rotor. It's constructed to form a solid steel forging so as to withstand the large centrifugal stress inherent in high speed operation. Cylindrical rotors cannot accelerate high inertia loads. They are limited in application to pumps, fans, blowers, and other loads. Salient pole rotor. This type of rotor, built for use with high inertia, low speed loads, have many poles projecting radially outward from the steel spider. These salient poles are bolted or keyed to the spider, and then spider is keyed to the shaft. A salient pole rotor with a shaft mounted DC exciter. DC current from the exciter armature is supplied to the field winding by means of carbon brushes. A brushless excitation, or this is the operating principle of synchronous motor. It works on the principle of magnetic locking. It works on the principle of magnetic locking. When two unlike poles are brought near each other, the magnets are strong. There exists a tremendous force of attraction between these two poles. In such a condition, the two magnets are said to be magnetically locked. If the rotor poles are rotated by some external means at such a speed that they are interchange their position along with the stator poles, then the rotor will experience a continuous unidirectional torque. A synchronous motor cannot start by itself. In order to make the motor self-starting, a squirrel cage winding is provided on the rotor. The damper winding serves to start the motor. To start with a three-phase supply is given to the stator winding. The rotor field winding is left unenergized. As the motor approaches the synchronous speed, the rotor is excited with a DC current. Thank you.